Okay, so we're up to the last two examples in chapter 6, example 11 and example 12. And these are just additional examples where we have to calculate binomial probabilities, and we'll practice using the calculator. So example 11 says, a test consists of 10 multiple choice questions, each with 5 possible answers, one of which is correct. If a student randomly guesses, what is the probability that A, the student will get exactly 6 questions correct? And then we have parts B and C, which we'll worry about in a little bit. But the first thing I want you to realize is that when you read this question, this sounds like a binomial experiment, right? Because imagine you're taking a multiple choice test and there's 10 questions. Each has 5 possible answer choices. Only one of them is correct, right? So let's say there's a question on a test and it has options A, B, C, D, and E, right? So these are your multiple choice options. Only one of them is the correct answer. That's what I'm saying here. So if we're going to guess on all these questions, what's the probability that we're going to get exactly 6 questions correct? So definitely thinking a binomial experiment, because there's only 2 possible outcomes when we guess, right? We're either going to get the answer correct or we're going to get it incorrect, right? 2 possibilities. And we have n independent trials, right? Meaning there's 10 questions. So we're going to have 10 shots at this. So there's 10 stages to this experiment, and they're all independent of each other, meaning if I guess on the first question, me guessing on the second question and getting it right has nothing to do with the outcome of the first question, right? All these questions are independent of one another. And we could think of these 2 categories as a success and as a failure, right? So we're interested in the probability that the student's going to get the answer correct. So we're going to consider a success getting the answer correct. And for any given question, the probability of a success or the student guessing correctly is always going to be the same, right? If there's 5 possible answers, only one of them is correct. So the probability for any one given question of getting it correct is going to be 1 out of 5, right? Because there's 5 total choices and only one of them is correct. And 1/5 is equal to 0.2. So that's really going to be the probability of being successful, right? Guessing and getting it correct, 0.2. And that stays the same for every single question because each question has 5 possible answers. So we just satisfied the conditions for a binomial experiment. So since this is a binomial experiment, I could use the binomial probability formula to answer these questions, which we'll do, but let's make the calculator do it. Let's use the binomial function in the calculator, but first we need to know our parameters, right? So we're considering a success if we answer correctly, right? So let's jot this down. There's n equals 10 trials to this experiment, right? Because we're answering 10 questions. And the probability of a success P, right, which is the probability of getting any one question right, we said is 0.2. So the probability of a success is equal to 0.2. Which makes the probability of failure, I'm going to write it down, even though we don't need it for the calculator. The calculator already calculates that for us behind the scenes when it plugs into the formula. But I just want you to realize that if the probability of getting a question correct is 0.2, what's the probability of getting it incorrect? It's going to be 0.8, right? Or 4 out of 5, because 4 of the questions are wrong or 4 of the choices are wrong, right? Out of the 5, there's only one correct choice. So, or you could think of it as 1 minus 0.2 is equal to 0.80. And we are trying to calculate in part A the probability that the number of successes is equal to 6, right? Because a success is if we answer correctly, and we want to know what's the probability of getting exactly 6 answers or yeah, 6 questions, I should say, correct. So we're going to use the binomial formula in the calculator. And I already know N, P, and S, right? There's N equals 10 trials. The probability of a success on any given trial is 0.2, and we want 6 successes. So we're going to plug this right into the calculator, and we're going to use binom PDF since we're calculating exact. So let's go to the calculator. Let's pull up binom PDF, so second and then the vars key. And then we're going to scroll down to option A, which is binom PDF. So the number of trials in this case is 10, because there's 10 multiple choice questions. The probability of a success we said is 0.2. And in this case, we're interested in calculating the probability of getting exactly 6 answers correct. So X, which is like our S, right, in the formula is 6. And now we can paste and then enter. And we get about, let's go 4 places. So we get about 0.0055. So that represents the probability that if we guess on all 10 questions, we're going to get 6 of them correct. Notice that's a really, really small probability. It's less than 1%, which makes sense because really it's not, the odds are against you. If you're going to take a 10 question test and each question has 5 choices and you're just going to guess, it's not very likely that you're going to get a lot of them correct, as you can see by this outcome. All right, so let's look at part B. And let's just write down N down here so we can see it. So N is 10, P is 0.2. And now in this case, we want to find the probability of at most 4 questions being correct. So this is the same thing as saying we want at most 4 successes. And that's not the same thing as exactly 4, right? At most includes 3, 2, 1, and 0, because the most we could get is 4, but we could also get anything less. And it is possible to get 3 questions correct, only 2, only 1, or even none. So at most 4 includes 0, 1, 2, 3, and 4. We don't have to worry about calculating all those by hand because we're going to make the calculator do it. But we're going to use, since this is at most, this is when we have to use the binom CDF function. And it's going to get that cumulative probability for us. It's going to add up the probability that we get 0 correct, 1 correct, 2 correct, 3 correct, and 4 correct. And it's going to do it very quickly for us. So now we have to go to the calculator and plug in our parameters. So second, the vars key, and now we're going to pull up binom CDF for the cumulative function for at most. So the number of trials is 10. The probability of a success or getting an answer correct is 0.2. And now we want the X value, which is at most how many successes, right? And we want at most 4 successes in this case. And so we paste. And we get about 0.9672 if we go 4 places. So this is equal to 0.9672, which is a pretty high probability. So the chances that you're going to get at most 4 correct, which could be 0, 1, 2, 3, or 4, is pretty high because it's likely you're not going to get a lot correct when you're guessing, right? So it's going to be about a 96.72% chance that you're going to get at most 4 questions correct. So let's do part C. Part C says, what's the probability that the student will get at least 3 questions correct? Now, here's the thing. We only have 2 functions in the calculator. We have binom PDF, which is for exact amount of successes, and binom CDF, which is for at most. We don't have a binomial function in the calculator for at least. But what we could do is we can manipulate the at most to figure out at least. And this is what I mean. So it's possible that we could get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 questions correct, right? Because this is a 10-question test. We're interested in finding the probability that the student will get at least 3 correct. Well, what does at least 3 include? That includes 3 or more, right? At least 3 is 3 or more. So 3, 4, 5, 6, 7, 8, 9, 10, right? This all includes at least 3. Remember what I said, we don't have a function in the calculator to calculate at least 3 successes. But I do have a function in the calculator that's going to calculate at most as successes, right? So what if we did this? What if we took at most 2 successes, right? Because 0, 1, and 2 means at most 2, and that's what we don't want. We want everything else, the probability from 3 successes on all the way up to 10. What if I did 1 minus the probability of at most 2 successes? Then that's going to leave me with everything else, right? At least 3, 3, 4, 5, 6, 7, 8, 9, 10. Because if I were to add up all those probabilities, remember, the probabilities of all the events in a sample space are going to add up to 1, or the outcomes, I should say. So if I do 1 minus what's in red, that's going to leave me with everything else that's in the blue. And I know how to do that because that's at most, and that's binom CDF, right? So we could do 1 minus at most 2, which is what we're going to do. So let's go over to the calculator. So we're going to do 1 minus, now pull up the binom CDF, so second and then the vars key. So binom CDF. The trials is still 10. The probability of a success is 2. But now we want at most 2, right? We're subtracting from 1 the probability of at most 2. So that leaves us with everything else, 3 on. So at most 2. So we're going to plug in the x value is 2. And then enter. And we get about 0.3222 for the answer. So 1 minus the probability of at most 2 correct is going to leave us with at least 3 correct. So we just had to manipulate our function a little bit, our CDF function. So this is going to be 0.3222. So I'm going to stop here. You know what? I was going to do 1 video with these 2 questions. This was a lot, so let's just stop here. I'll let you, absorb what we just did, think about it, practice, and then I'll do example 12 in one last video for chapter 6.